we're moving out of module 2. We're into module 3 now. You can see we've got quite a few vocabulary words for today that we'll be going through. Our biggest learning goal, we're looking at a number related to power. We're going to look at perfect squares, perfect cubes. We're going to be writing out and evaluating numeric expressions, whole number exponents. And we're going to finish with the order of operations, Dan's favorite pieces. But to get us ready for all of the above, we're going to start with a quick review activity. We need you to write the power of 10 as a product of factors, and then calculate the product. There's 2 parts for this. You're rewriting it as multiplication sentence, and then you're going to actually do the calculation. It should take you all about 30 seconds. We'll give you a minute. You get going. On the first one, remember that this one is just telling you how many times I'm multiplying that by myself, right? So for this one, I'm going to rewrite that as 10 times 10, which is 100. 5 of 10. So I'm going to write 10. 5 of 10. That would be 5 zeros, 100,000. This one is going to have 3 10s. That is 1,000. This has 4 10s. 2, 3, 4. So that one is going to be $10. Pretty easy, right? When you're using the base power of 10, then your exponents become super easy because all you're doing is adding zeros. Okay, so with that concept, let's go to page 346. And this one, what we've done before is worked a lot with area and volume already. When we have a special shape like a square, all sides of the square have the same length and width. So that means I can change my formula a little bit. I know that area is going to be length times width, but those are now the same, aren't they? So I can rewrite that as the side times the side, which using exponential notation, we can write it as side squared. Same thing happens when we do a cube. If we look at volume, because all sides of the cube have the same length, width, and height, then we can use the volume form of the cube as side times side times side, or side to the third power. So what we're going to do is, using those special shapes, a square and a cube, we want you to write the area of each square as a repeated product, as a square number, and as an area in square units. So how many things do you need to do? Things for each of these problems. You're writing it as a product, you're writing it as a square, and then you're solving it. Okay? So make sure you do all those. So you've got 3 of those to do with the area, and then you do the exact same thing with the volume of the cube. You do the same thing. Repeated product as a cube of a number, in other words, to the third power, and as a volume in cubic units. Okay, so you have 6 problems to do. You have 3 sub-problems for each of those 3 problems. So you actually have 18 problems you need to do. Most of them shouldn't take you long. We'll give you guys about 7 minutes. Go get started. You look at the table if you need to. Let me give you an example. This is going to be good enough. Guys, literally, all you're doing is using these formulas. So I'm writing it as a repeated product. Area equals 2 inches times 2 inches. I'm writing it as a square. Area equals 2 inches squared. And then I'm going to solve it. 2 times 2 is 4 inches times 6 is inches squared. So the second one's exactly the same. Okay, let's go through the rest of them real quick. Now, literally, all you need to change is 4 times a half, right? Exponent. It is actually important that you put the whole thing in parentheses. I'll talk about that in just a second. Doing math for multiplying fractions. What do I do? What? The whole number into a fraction? They're already fractions, 1/2 and 1/2. Variable finite. Jordan?
Yes. No.
Go across. 1 times 1 is, 2 times 2 is, 3 times c is, c squared. Okay? So there's my answer for this one. Now with the decimal, does it change anything? No. All I do is I write it. 1 and 2 times 10 times 1 2 tenths. For exponential form, I over decimal, I'm just going to write the numbers down 1 and 2 tenths. 1 and 2 tenths. I count my decimals, I got 2 of them. Now I'm just multiplying 12 times 12. So it gives me 4, 2. Don't forget the 0 for your place number as you move to the 10th place. 10, 1, gives me 4, 4, 1. And then I put my 2 decimals into my answer, so I start at the back. I go 2 decimal places. So my area is 1 in 44 centimeters squared. Okay? Any questions on the first 3?
Nope.
Okay, our next 3. The only thing that is changing now is we're doing volume. That means I have one more measurement because I have a length, width, and a height now. So for my side length on the cube, my volume is going to be 2 inches times 2 inches times 2 inches. Or if I do it in exponential notation, again, I need to have those parentheses because I'm cubing both the 2 and the inches. Now we just do the math. What's 2 times 2? 4 times 2?
8.
That's going to be 8 cubic inches. With a side length of 5 feet. Again, all that's going to change is what I'm putting down. But the format will always be the same. Same formula. 5 feet cubed. Here's where I saw a lot of people getting into trouble. Is this just 3 times 5?
Oh,
No, it's 5 times 5 times 5. Well, what's 5 times 5? 25. 25 times 5. 125. So for all of you that got 15, that explains why. This is not repeated addition, it's repeated multiplication. That's why, remember, if I write it as multiplication, that means I'm adding repeatedly, right? But when I write it as an exponent, that means I'm multiplying it repeatedly. Our last one, again, all the changes, we're now using a fraction, but I'm rewriting it 3 times for length, width, and height, or length, width, and height. Then I'm going to put it into cubic notation. Then I'm going to actually do the math. It doesn't change it in practice. Same concept. But 1 times 1 is 1 times 1 is 1 times 3 is. Yeah, side note, because a lot of you are talking instead of listening. And this is a really important concept because you're going to do all this math on the test and you're going to get half credit because you don't pay attention. Because this is really, really important. If my units, I'm going to erase this right now so I have room to do it. You might want to add this on your paper somewhere. If I have something like this, and I measured that, that would be 1 foot. If I'm looking at area, then it's going to look something like this. That is 1 square foot. If I'm looking at volume, volume is going to look like this. That is 1 cubic foot. Do those look the same?
No.
But they all have 1. So they're all 1.
No.
1, that's 1, that's 1. Those are all 1. Do the units matter?
Yes.
Absolutely. For the volume, and then you give me an answer. Are you correct?
No.
No, you're not. Does it look like this with the volume? looks like this. So do you need to pay attention to what your units are? This is why the engine has to be inside of the parentheses. Because if I don't, I'm not actually doing the math properly. Because these are both inside the parentheses, squared and inches squared. If I had just written that 2 inches squared, that's actually a measure. That's not a formula. This is completely different. Because now it's 4 inches squared. Do you see the difference? Do you understand why the units matter? And you would not understand why the units matter. And I'm literally giving you a picture to show you why the units matter. Because what units you put gives me a completely different picture of what your answer means. Nobody okay with that? Okay. So when we start testing on this stuff, and you get credit taken off, you'll understand why. And we can always come back to this. Okay, so we've given you a practice. We just gave you a base formula. Now we're going to see if you can apply it. So we do the same thing. We want you to do a cumulative equivalent numeric expression for each perfect square. So you can write it as a product, and then you're going to evaluate or solve it. So you got 2 of them to do. We'll give you guys about 30 seconds. I'll give you a minute. It'll take a second. So the key way you should have done it. You should have written it as 6 times 6. And then 12 times 12. Look it up. I will say, having walked around, seeing a very troubling thing. We've been together for almost 3 full quarters now. And I still have people that are throwing variables into my sentence. Why are we still doing variables? Because if I were to rewrite this, I would rewrite this as 36x. Because this is not a variable. This is our most commonly used variable. The 2 most commonly are x and y. When we try to graph them, you got to be moving into a lot more of that as time goes on. But x is a very common variable, so we're not using it to show multiplication anymore. Okay? Okay, everyone should have your highlighters. Quick side note, on my side, I got a whole bunch of highlighters in. If you need a highlighter, borrow one, put it in the class. Fine. That is to evaluate a numeric expression. So in math, if you hear the word evaluate in your directions, what we're asking you is rewrite the expression as a single numeric value. Another way to think of it is we're asking you to solve it. So to evaluate it means to solve it. This next piece, we skipped the page, so I'm not going to go through the diagram. If you want to get this. So if we're going to rewrite this expression, 7 minus 3 squared plus 10 minus 7, what we're going to do is the piece inside parentheses we're going to do first. So 7 minus 3 is going to be 4 squared plus 10 minus 7 squared. Then I'm going to do the 10 minus 7. So that becomes 3 squared. Then I do 4 squared. What's 4 times 4? 16 plus 3 squared. Then I'm going to do 3 squared. What's 3 times 3? 9. So 16 plus 9 gives me 25. So when I say evaluate, what I'm saying is I want to see all these steps till you get to an answer. Get it down to 1 digit. That's what evaluate means. This is making sense so far. This? Right, outside front, inside it gets weird. But we'll talk about that in just a second. Keep that thought though. Now, the next answer we have is what we call perfect cube. A perfect cube is any number Any number you can express as the product of three equal whole numbers. Okay? We've given you a table with the first 10 numbers as perfect cubes. You can see that as I start at 1, it's just a 1. But by the time I get to 10, I'm already to 1,000. So this goes up really, really fast, guys. So if you ever hear the term, it goes up exponentially, what they're saying is it's going super fast. Your numbers get huge when you start doing exponents. This is only to the third power. Imagine when you start getting to the seventh and eighth power. Those numbers get massive. That being said, especially for those of you that are interested in getting into or trying to get as much math as you can in high school, you should memorize this whole chart because you will be using cubes a lot in higher mathematics. So the sooner you can memorize this, the better off you will be. So you may want to like put a little dog ear on this. We do have two different terms. If I have a power of 3 mathematically, talk about it, I'm going to call that 6 cubed. We'll give you another way to say it in just a minute. One that was on the previous page that we skipped that I do want to make sure you take note of. The same thing. If I have an exponent of 2, you can read this. If I have an exponent of 2, I call it squared. If I have an exponent of 3, I call it cubed. Right? You write this down. Everybody good on these terms? Okay, let's go to our next page then. Okay, 349. We've already practiced using the square. Now we want you to practice do 2 more equivalent using the perfect cubes for these 2 numbers. So write it as the common factors and then evaluate. We'll give you guys one good. So same as before, guys. If I write it as repeated, to do the evaluation, now multiply 5 times 5. 5 times 5 is 4, then you already do that. Next one, I'm going to write 2 times 2 times 2. That means 2 times 2 is 4. 4 times 2 is 8. Okay? Here is going to be really one of the more important parts of the lesson, probably the second most. The most important is going to be our last part. But this is breaking this down to help everybody understand what it is we're talking about. In general, we can do represent repeated multiplication as we call a power. Here's the irony. Most people, when you think of exponents, you actually are thinking about a power. Because when I write this whole thing out, this is a power. The power is made of 2 pieces. The 2 pieces that you put together to get a power are the base. And our base is just the number that is being multiplied by itself. Okay? So you can see there are 4 2's. The 2 is the base multiplied by itself. The other piece of it is our exponent. The exponent, if I count up how many times the 2 is multiplied by itself, that's what the exponent is. I will tell you guys up front, one of the best things you can do to help you get the right problems, right answers with these exponent problems is taking the time to rewrite the problem as a product of the factors. I think that most of you on this one, if you saw 5 times 5 times 5, most of you, if you took your time, are not going to put 15. But if you think of 5 to the 3rd power, there are a lot of you who are just going to do 5 times 3 and get 15. That is not correct. Is everybody clear on that? Okay? So, for example, 2 to the 4th power, what does that equal? Oh, that you do?
Yeah, it's 16.
You told them it was right.
Yeah, it's 16.
How many of you thought? Don't raise your hand. But if you thought it was 8, I hope you understand why you're wrong. Because it's 2 times 2, which is 4. 4 times 2, 8 times 2, which is 16. So both of you are going to look at 2 to the 4th power and go, oh, that's 8. No, it's not. Same thing here. 7 to the 5th power. What is that going to equal? For those of you who already have the answer, you're wrong.
Okay, so
Okay, now second part. This is what you identify each power, each power in words. Give you a little sidebar here for how we actually talk about this mathematically. So we write it like this, but when we talk about it, here's 2 different ways we have said this. You can say 2 to the 4th power, or 2 ways to the 4th power. So a couple different ways you can do it. Again, you have 2 special words. Squared is the power of 2, cubed is the power of 3. Other than that, you're going to need to use some format like this. Okay. Let me set this up to help you guys a little bit. What I'm saying, tell me, what is the base? What is the exponent? And then you're going to write it in words. Okay? So you have 3 things to do for each of those 2. We'll give you guys about a minute. Blank in this case is 7. Exponent, that's my little number. 5. How can I say it? 7 power. Or you can say 7 to the power of 5. Next one is 4. My exponent is 8. And I'm going to set this one as 4 to the power of 8. Either way would work. You just need to make sure that you understand what I'm saying. Basically, the way the wording goes, whatever my basis comes first, whatever the power is, whatever the exponent is, goes right before the word power. Any questions on this part? Okay, so far, it's all been just kind of formatting. Because of time, we're going to skip to page 252. If you want to. Those are both big numbers. I have to work them out first. This is a really important piece. When it comes to mathematics, the order of operations is kind of like our Bible. This is the 10 Commandments. This is what every mathematician has to do. The order of operations is a set of rules that ensures the same result every time you do it. Because we have these rules, any mathematician in the world that looks like at a problem will get the same answer. Because there's only one way you can do the problem. Okay? The first thing we're going to do is evaluate expressions inside parentheses or grouping symbols. Our second one, we're going to look at the exponents. Our third one, we're going to multiply and divide, going from left to right. And our fourth one, we're going to add and subtract from left to right. Most of you should have had exposure to this in your years. Many of you have probably heard something like, please excuse my hand salad. Does that sound familiar? Okay. We do have some issues here. The biggest issue is Aunt Sally has been leading you guys astray. We're changing this. Get out of here, Aunt Sally's dead. Aunt Sally is dead. If you look at that phrase, how many steps are there? actually
4.
4. Here's why it's how they had to go. We made it sound like there are 6 steps. There are 4. So we have now changed it. We are now going with Gemma.
Oh,
Guys, listen up. This is one of the most important parts of the lesson. This is the most important part of the lesson. We really need to get rid of Jay and Sally because that's not right. The biggest problem with this is multiple people said, oh, I have to multiply before I divide. That is multiplication and division is one step, and go from left to right. With the addition and subtraction, now one step, and I go from left to right. In other words, if there is a subtraction to the left of an addition, I will do it first. Okay? So we really need to get you guys focused on the Gemma. And we want to get you a little bit of practice. So go to page 253. I will tell you guys up front for this and for the test that you will be having on this. One of the first things you should do is write Gemma right at the top of your paper. That gives you a guideline to make sure you're going through each of the steps. So G is I'm looking for grouping symbols. Anything inside of a parentheses or a bracket, or if it's a division bar, things on top and then things on bottom. Exponents, we've been doing those all morning. Multiplication and division goes from left to right. Then addition and subtraction goes left to right. Do not skip a step. If you skip a step, you'll get the wrong answer. So we're going to get about 10 minutes left. We still need to go over homework. Only got about 5 minutes left. So we're going to give you guys about 3 minutes. Try to get as many problems. Then I'll knock about 4 of them out. Do a couple of these first. Guys, when you're doing any of these order operations problems, you really have to go through step by step. I can tell you right now, the people who are going to fail this test are the ones that want to take shortcuts. If you don't take shortcuts, these aren't hard because the Gemma tells you exactly what to do. So I go through. Do I have any grouping symbols on problem 1? No, so I cross it out. Now I'm on my exponent step. So I go through. Do I have exponents? I know I'm going to be doing that. Anything I don't do, I need to rewrite. So when I look at this, here's my exponent. So I'm going to rewrite everything else. 28 divided by, I can do this math now, what's 2 squared? 4 minus 36 divided by 3 squared. I still have an exponent. So now I'm going to do this step. I rewrite everything else. 28 divided by 4 minus 36 divided by 3 to the second power is 9. Do I have any more exponents? No, so I cross that off. Now I'm going to do multiplication and division from left to right. So I just start at the left. Oh wait, here's the division. So I'm going to do 28 divided by 4, 7 minus 36 divided by 9. I still have a division that I need to do. So 7 minus 4. Now I'm down to just the subtraction, so this answer is 3. Does this make sense? Guys, that may look like a lot. Did that take long? No. But if you will rewrite it, you will do it one step at a time. You're going to be accurate. You start taking shortcuts, you will get it wrong. Okay? Our next one. Here's what we mean by grouping symbol. You see the parentheses? That means I have to do this grouping, anything inside that grouping symbol first. That becomes 12 plus 25 divided by 5 is 5 squared. Once I'm done with one number inside of a grouping symbol, that is just whatever that number is. In this case, it's an exponent. So that's going to be my next step. So I've done my grouping. Now I'm going to do the exponent. So 12 plus 5 squared is 25. I don't have any multiplication or division, so I'm just going to add. Put those together, I get 37. Is this making sense? Okay. I would highly recommend doing the rest of this page because it's going to give you good practice, but let's go to the homework because that's also going to give you good practice. On your homework, your journal entry is a little bit different this time. You're going to do your own line for the order of operations. So, the old one used to be, please excuse my dear Aunt Sally. That's what we call a mnemonic. It's a sentence that uses the first letter of each word to help me remember what the order is. But now our order is Gemma. So you're going to put those letters, put 4 words together to make a sentence. You use whatever you want, whatever you can help you remember that it is now Gemma. So that's your journal entry. That's one of your easier ones. Here's the important part on your homework. We're cutting this out. We didn't really cover drawing the models. Honestly, neither McKenna or I think the model is that important on this piece of it. So we're going to cross that out. You don't have to draw models. We just want you to draw these expressions for 2 times 5 squared. So you're just gonna, all you're gonna do is evaluate the expression. Go to the back page. This is the bulk of the assignment. You've got 8 problems. Use the order of operations to evaluate. What does evaluate mean? So I wanted you to get down to one number. Questions on your homework? Okay. Good news. Bad news is the type deal. Our presenter isn't here yet. So I want you guys to go back to 253. 253. Solve as many more of them as you can until our presenter gets here.